session. Yeah, so I've been solving hackering problems lately, and I need to take a screenshot of it because I want to keep track of my ranks in hackering. Oh, actually, I did. Okay. Anyway, so as of now, my rank is 636,000 to 424. Yeah, so um, let's go and solve some problems. Print element of a linked list. So if it is it says success rate is 97%, and insert a node a tail of linked list, insert a node a head of linked list, insert a node a specific position of linked list, and delete a node. Okay, so print in reverse. So all this assembly is pretty simple. So what I'm gonna do is I'm gonna set a timer. So 6 to 7. Okay, so I will stream for 1 hour and we will see how many challenges I can finish within 1 hour, and then after that we will come back to the ranking and see is there any changes in my rankings. Currently I'm 600,000, so I don't want to be there.
About going to the bathroom in public. So
okay, I don't like to listen any ads. Okay, so let's go and start with printing elements of linked list. The linked list. So, if anyone of you don't know what linked list is, so linked list is a basically a data structure where you have a node. A node is so node there in a node you have two elements. One is the value of the element, and the second one it holds a it holds the location of next element. So say the okay, so let's everyone know what array is. So array versus linked list. Linked list. Okay, so what is difference between array and linked list? So array is also a data type, a type of data structure where you store like elements like 1, 2, 3, 4, 5, and you can access them by access them by um access them by indexes, indices. Okay, so indices, you can access them by indices, and accessing is queue of 1. That means it is constant because you can access a specific element in an array by its element. And unlike unlike array, linked list is maybe one holds one, and it also has next, right? Next holds another 2, that equals 2, and 2 holds next. That will be another object. Say 3 holds 3, and it has another, say, next. It has maybe a 4, and it has 4 inside it. And okay, so let's remove this to make it same like this. So Um, so this is linked list. We need to accessing, but inserting an element is q of n, because when you want to insert an element inside this between 2 and 3, what you need to do is you need to traverse through the array and then put this and then push this back, so that makes it q of n. So we can't access them, but accessing it is q of n, because we need to find, like we can't jump to the third object, like we can't jump straight away to the third object. We need to start from the one, and one has next, that is two, two has next, that is three. So so accessing it takes time, but inserting it is easier than erase q of 1, because if you want to insert something, if you want to insert something here between here, what you want to do is one dot. Okay, so actually this is wrong. The way I structured the data is wrong, because one has two, one another is value, and the like another is value. Well, maybe we can say well, that is one, and next that will be this. Okay, so we made a mistake, but okay, so anyway, leave it like this. Okay, so what we need to do is we need to print the we need to print the linked list. So we get head. So let's say let current. So we need to current node equals head. Okay. So while current node, okay, current node, what we need to do we need to console log, right? Okay, console.log current node. Okay, current node dot value. Is it value or data? It is data. Okay, so data, and we need to say current node equals current node dot next. Okay, that's it. So that's it. Yeah. Come on, yes, so it went through. Inserting not a tail. Okay, so what we need to do is we need to do the same thing, that current node equals head, and I really care about indentation. Okay, so while, okay, current node. Oh, why it is always current line? Okay, while current node, what we need to do is, so we need to add a node at the end of the head. So what we want to do, what my thought process is, I want to traverse, iterate through, I need to traverse through the node linked list, and I will when I reach the end of the linked list, so um, the end of the linked list, like last node, we have some property that is next points to point points points to null. Why? Because we don't have next, because it is the last element, so he don't have next element. That's why it's point to null. So we need to find that last element. So current.next, while current.next, if it has a next element in it, so what we will need to do is current node equals current node dot next. Okay, and yeah, so we get the current node that is current node dot next. Do we have to create a new node? String. What do we need to do? Okay, let's say main. Okay, so current node next equal to this, where data equals data and next equals null, right? So this will be our code. Do we need to return this? Return head. Okay, let's run this. Hmm. Hmm. What? Hmm. It create a new node. Okay, so singular list new node equals new single data. Okay, what is the problem? Hmm. Well, what is the problem? Okay, this is in Java. Oh, I'm getting mixed up. So let new node equals this thing, and what we need to do is current dot next equal, okay, current node dot next equals new node Okay, so this will not work. Okay, so we got now. If there is no next, then head dot next, head current node dot next. If there is next, okay, okay, current node. So what I'm gonna do is instead of this, what I'm gonna do is I'm gonna try something else. What I'm gonna do is if current node dot next. Hmm. Next, if this is false, then what I'm gonna do is I'm gonna break this break. I'm gonna break this loop. Mm, else symbol output. Let me see what is symbol output. Okay, so let's do this. Let's run the code and see what symbol output 5. Hmm. What is the problem? Okay, singular. Okay, so function read line. Node. Did we do node? Okay, single linked node list. Node. Okay, yeah, that's what made ours very confusing. Okay, so instead of this, what I'm gonna do is console.log current node and new node. See what are see what they are. Mm-hmm. Okay, so we gotta. Mhm. Okay, so this is not working, right? So let current node. Okay, so current node. If there is current node next, let's go this. Otherwise, okay. You know what? I'm gonna hold something. Let preview previous node. I'm gonna hold previous node in here. So head. Okay, so our current node. Okay, and I'm gonna hold this previous node equals current node. Okay, so what I'm gonna do is previous node here, and see what I am getting. So this should fix the problem. Hmm. Am I running a loop? No. What? Why is so many debug output? Where am I doing my console logs? Okay, so I'm doing console logs outside of these, but why? Okay, why it is still now? Well, hmm. Wait, why new node has this? Okay, it's not clear enough. Let's try to figure this out. Hmm. Previous node and new node. Node. Okay, previous node. Okay, space, new node, space. Let's do this and see. Mhm. This is really weird. I don't know why. Okay, so I'm gonna print my. Wait, it's not even in the loop, so why it is running so many times? Okay, so now I understand what the problem is. I didn't read the problem correctly. So what I need to do is I need to have the head. So let new node equals a linked singly linked list node of data, and head dot next points to new node. That is just inserting the data. So why is it inserting at the tail? Oh, hmm. Yeah, new. Did we? Oh, I'm sorry. We should do this of null. So it is null because I don't know. So let's see. Let's collapse these things because they're so annoying. Let's see what head is. Console.log head, and let's see what head is. Okay, let's just see what head is, and then we can go from there. Console.log head undefined null. So initially it is null. Okay, so we need to do two things. If okay, so this is true when there is head. Oops, shoot. This is true when there's head. So we need to remove this. So if there is head, if head, there's head, there's hop. Okay, so we can do this, right? Else, if there's no head, then if there is head, we need to do something, and if there is no head, then we need to do something else. So let current node equals head, and then else we need to just head equals new linked list node, simply linked list node data. Okay, so this is what we need to do. Okay, so while cran dot next, we need to go cran node equals cran node dot next, and instead here cran node next is new node, and then we return the head. Okay, so this is how we return. This is how we do. This is how we do. Okay, we're gonna submit the code, and we'll. Okay, what is time? 6:24. So we still have 40, no, 30 plus minutes. We still have over half an hour. And let's go to the next challenge. So insert node at head. So this is a bit tricky. Okay, in head, insert. Okay, so insert. Okay, okay, so let current. Okay, anyway, make this header and okay. So this is inserting node at head. So what we need to do is if there is head, then what we need to do is let if there is head, then head equals current node current. Okay. Let current node equals head, right? And we create what we create and let new head equals new singly linked list node, and we pass the data there. So new new head dot next equals current node, and head equals new head. Okay, so this is the head if there is data in the head. If there is no data in the head, else if there's no data in the head, then let's head equals new singly list node data, right? That is easy. So at the end, we need to return the head. That's it. Yep. We did it, boys. So we did it. We did it. What was our ranking again? 600,000 for something, 200 something. So after these three, like few, yeah. Okay. Insert node at position. Okay. What is position? Console.log position. Okay, let's say position is 2. Okay, so position is just a number. 1, 2, 3, and data equals 4. Position. Okay. Net counter equals 1. So it starts with 1. And I always care about indentations. Let what was that? Let a current node equals the head, right? And let okay, so while counter is less than equal to position, what we need to do is current node equals current node dot next. Okay, so we need to find a way. Okay, so we will leave that for now. Okay, so current node counter plus plus And when counter hit at the position, we have okay, we need to track the previous node, and I'm gonna do this, and then I'm gonna try to explain what's going on here. So let's say head, and then current node is previous node, node previous node equals current node, and counter plus plus. So what we need to do is previous node dot next equals let modified node, okay, equals previous dot next. Okay, I don't know. Okay, previous dot next, previous dot next equals what is new singly linked list node of data. So that is the previous node next, and a modified node is previous node dot next. Okay, so instead of modified node, a new node, make it new node, previous dot next. Okay, so new node dot next equals current node. Okay, and we want to return the head. Okay, this will work. I am confident. Yes, so it did work. Okay, so I'm gonna go through this and try to do may try to explain what's going on here. So what they're asking me to do is they gave us a linked list, and they give us a data, and then they give us a position. So if this is the 1 and 2 and 3, and we will do one more because we can. We'll do one more because we can. Okay, so this is the linked list they put in. Okay, I'll remove 4 here. Okay, 4 here and put 5 here. So they want to insert 3. Add 3. So they pass something. Okay, so head, this is equals head. So they pass this something like this. Head equals this, and what we need to do is head data equals 3, and position equals 3. So what they passed is they want to insert this data at position 3. So 1, 2, 3. That means they want to insert 3 here, and then move 4. And we okay, so we will do this. Return something like this. Return, and what we need to return is 1, 1, 2. Okay, 2, 3, 4, 5. Okay, they want to return something like this. So in this scenario, what we did was we set up a counter that starts from 1 because it is not indexed as per the example they gave us here. So we started with counter 1, and we head equals this is current node, and this is also previous node right now. Okay, so right now this is the, so the head is the this thing one, so one is where one lies. Okay, so one is currently the head, and the one is the head, and then that has all these 2 4 5, and so we assign the head to current node, and current node becomes this also, this thing also, and we also assigned head to the previous node, and then previous node becomes this too. Okay, so we enter here, we said when counter is less than position, less than or equal to position, we want to go to. So at first, counter is 1, that is less than 3. So what we did was, we previous node is same as this, but current node is changed. Current node is now 2, right? And counter equals now 2. So 2 is less than 3. That is still, and 2 is less than or equal to 3. That is still good. Okay, so what we did was, the previous node is now 2, and then current node becomes 4. Okay, so counter plus plus. So counter becomes now 3. Counter becomes now 3. 2, 3. 3 is less than, okay, so, okay. I'm sorry, I need to explain this again. Okay, so when we here, what we did was, when we were here, counter is 1, current node is head, right? When we were here, counter is 1, current node, counter is 1, so 1 is less than position, and the previous node is 1, and now we change the current node to 2, right? And then counter becomes 2. 2 is less than and equal to 3, that's correct. So previous node now becomes 2, and current node becomes 3, which is 4. Okay, and then counter plus plus, that makes counter 3. Counter 3 is still less than, counter 3 is still less than 1 and 2. Let's go here. Okay, let's go again. I'm missing something. Okay, so I'm trying to explain here, but I'm missing something. But it's working. It's working in my head. It's working in the computer, but it's not coming through my mouth. Okay, so let's start over again. So when counter equals 1 and current node equals 1, then previous node equals 1, and then we enter here, counter still is 1, and then previous node still is 1, and then current node changes to 2, right? 2, and then counter changes to 2, right? So now counter equals 2, and current node equals 2, and previous node equals 1. So we come back again, and 2 is less than 3, and 2 is less than or equal to 3. So previous node now becomes 2, right? And counter previous node current node. Okay, so current node. Okay, so we counter the first round. Counter became 2, 3. The current node becomes 2, and then second round 2 is less than 3. 1, 2, 3. 2 is less than 3. 1, 2. Okay, so we need to enter 1, 2, 2, right? We need to enter 2. So 1, 2. We need to enter at 2. So this is 2. Position is 2. That's what makes. Okay, that makes sense now. So when now counter equals 2, current node equals 2, and previous node equals 1. And we came back again, and the previous node becomes 2, current node becomes 3. No, we don't have 3, so current node becomes 4, and counter becomes 3. And wait, counter becomes 3. Okay, so the position is 2, so counter is not less than or equal to 2. That means 3 is not less than or equal to 2. So we came out and we have current previous node, which is 2, right? And we have current node, which is 4. So what we did is current node previous dot previous dot next equals, we assigned a new linked list node. So now it becomes new linked list node with data of 3. So we have a linked list that has data of 3 and next of now. So what we did is the next of previous node, which is 2. So the next of 2 becomes 3. The newly created single linked list node, which is 3 and which doesn't have a next. So we said this new node is previous.next. Okay, so previous.next, which holds the data of 3 and the next of now. So now we set next of now, the new node which has data of 3 and next of now. So we assigned a new next, which is current, which is 4, right? So that way we returned head, so which has this structure. Oh my god, it's so hard to explain. Okay, let's submit this and get the stars. Okay, congratulations! You solved the challenge. Would you like to challenge your friends? Okay, I challenge you. I challenge you to complete this. Okay, so we will go one final thing, delete a node. So which is fairly simple. We have a position, so we already have the counter, which is 1. Okay, we need. Okay, so this time I'm gonna explain before coding, because otherwise I get hard time to explain. So say we have a head of something like this, head of 1 2 2 2 2 2 3 2 4. Okay, we're missing something, 5, and they send us 1 2 3 the position of 3, and we want to return something like, I need to copy this, it's really hard to type the thing. Okay, alright, so what we need to do is we need to delete this 2, and okay, so we are missing 1, so we need to return this thing. So the same this is this same idea we had before. We can use the same idea or same algorithm we used before. We said about counter, and then when that counter hits, when that counter hits at the position, then we will come out of the loop, and then this time instead of adding, we want to break the chain. So the 2 has next of 2, right? And then what we need to do is we break the chain. 2 has we have to break the chain, and where we will have 2 that next will host the node which contains value of 3. So we need to break the chain. Okay, so let's start coding. Let now head equals, no, we already have head. Let's current node equals head, and we will need previous node, of course. Previous node equals head. Okay, so while we will do while counter is less than the less than or equal to the position, what we need to do is we will say previous node equals current node. Oh, I'm always getting this. Okay, current node and current node equals current node dot next, right? And yeah, so we counter plus plus. So this time we have to do something different. What we need to do is previous node dot next equals current node dot next, because, and then we will return head. Now this will work, and after working this I'll explain this. Okay, it is working. So now I'm going to go through the code. So what we did was we have a position of 1 2 3 1 2 3. We need to delete this 2, right? So what we did was we have a counter which is 1. 1 is okay, so initially both current node and previous node is 1. Okay, so counter is 1 as well, so 1 is less than or equal to 3, that is true. So we go inside, and then previous node becomes 1 and current node becomes 2, and counter becomes 2, right? And then we go up here, and the 2 is less than or equal to 3, that is true. So previous node becomes current node, which is 2, and current node becomes 2, this is true, right? Okay, so now counter is 3. Okay, 2 3 3 is less than 3 is less than, okay, okay, 3 is less than okay, I still find it difficult to explain this. 1 2 3. Okay, okay, so okay, let's start again. I had okay, so in when current node is 2, and counter is 2, previous node is 1, right? And then we go up here, and previous node becomes 2, previous node becomes 2, current node becomes 3, and counter becomes 3, right? So we go up here again, previous node. Wait a second. One, two, three. Updated. Okay, so anyway, so what we did was we break the two and we connected to this two that next to three. Okay, so that way we became this thing. Okay, I got something to do, and I think I need to stop my stream here. And before we go, I want to see my hackering rank and see if solving these problems make any difference in my rank. Let's see. Oh, why? Why it is 2? Why it is wrong answer? Wrong answer. Why? Why? Why do you... How did it become wrong? Okay, so we need to make a test case. If position current node I need to do something. Okay, I'm gonna break this. See if that makes any difference. I still didn't do anything. Okay, so instead of this, I will do this here. Does it make any difference? Yeah, but didn't make any difference. Let's do this and see if it does make any difference. Okay, let's do this. Okay, we solve this. We solve every cases. Okay, let's do that. Then let's submit the. We don't want to go next challenge. Let's go and check my hacker rank and see if this demand any improvements. Problem solving. Let's see. Oh, it really made difference. Do you see that? Before it was like 600 something. Now it's like 500. Okay, so 500. My goal is to have like 500 rank, right? 500, somewhere around 500. Okay, yeah, I'm gonna do 500. I'm gonna stay like maybe not 500, 100,000 something. And if possible, then 10,000 will be perfect. And 10,000, if my rank is in 10,000, wow, man. Okay. Thank you for sticking, and see you in the next stream.